Hey, welcome back. Today, let's dive into autonomous landing in INAV. If you've ever used the default landing feature in INAV, you know that the home position gets set when you arm your craft. But what if you want to change that? No worries. You can update the home position by activating Home Reset while flying over the desired spot. Now, when you activate Return to Home, RTH, your craft heads to that home position at the set return to home altitude. Once it gets there, it spirals down and lands. But here's the catch. There's a real risk that the spiral descent might take your craft over the flight line, and that's a surefire way to get into trouble. Luckily, the awesome developers at INAV have a solution: autonomous landing. Today we'll go through how to set it up. Trust me, you're going to love this. How autonomous landing works. When you activate RTH in autonomous mode, your craft flies straight to the designated safe home at its current altitude. Once it arrives, it circles for about 30 seconds to measure wind speed and direction. If needed, it descends to the return to home altitude. Then comes the fun part. It flies outbound, turns 45 degrees, continues until it aligns with the extended runway line, turns 90 degrees, and tracks back for a smooth, controlled landing. Pretty cool, right? Setting up a safe home. The first step is defining a safe home, your landing spot. Here's how to do it. Open INAV configuration and connect to your craft. Click on the Mission Control tab. Click the Home icon. Select Load Safe Homes from EEPROM to see any previously defined safe homes. If you're starting fresh, navigate the map to your desired safe home location. You can zoom in and out using the plus/minus buttons or your mouse scroll wheel. Click the plus icon in the Safe Home Manager. A pin will appear on the map. You can drag it to fine-tune its position. Adjusting landing parameters. Now for the fun part, fine-tuning the landing settings. Approach direction. This determines the final leg of the landing. You can select a specific approach direction and exclude others if needed. You can also choose a left or right-hand traffic pattern. If no direction is set, INAV will pick one based on wind conditions. Fallback direction. This is a backup approach direction if the primary one isn't feasible due to wind conditions. Approach altitude. The altitude the craft will maintain before the final descent. You'll see two circles on the map. The inner circle is where the craft will circle to determine wind conditions. The outer circle marks the farthest distance the craft will travel from the safe home before beginning its landing approach. Once you've set everything up, don't forget to click the Save to EEPROM to store your settings. For more precise control, check out the Advanced Tuning tab. Here you can adjust final approach length, controls the landing pattern size including the base leg. If your craft doesn't exit the circling phase, you might need to increase the maximum wind tolerance. Pitch to throttle settings. Adjust this if your craft requires a steeper descent. Make your tweaks, click Save and Reboot, and you're all set! Editing or deleting a safe home. To edit a safe home, go to Mission Control, then Home icon, then Load from EEPROM. Select the safe home you want to modify. If you have multiple, zoom out to find the right one. Click the pin, make your changes, and save to EEPROM. To delete a safe home, click the safe home you want to remove. Click the trash can icon. Save your changes. Time to fly. Here's what an autonomous landing looks like. If you're flying FPV, you'll see a safe home indicator in your goggles when you arm your craft. When you activate RTH, your goggles will display Diverting to Safe Home. Your craft will fly to the designated safe home. It will maintain its current altitude or climb to the RTH altitude, whichever is greatest. Once over the safe home, it will circle for about 30 seconds to determine wind speed and direction. During this time, it will descend to the approach altitude. Then, it will fly outbound, turn about 135 degrees, fly to the extended runway center line, and track back. It will slow, flare, and land according to the settings you've defined. Isn't that amazing? And it's all autonomous. I hope this video has helped. Thanks for watching.